Now that we're done with the last question, let us try and solve another one. Now this question is a particularly important question because we're going to try and find bond order, paramagnetism, stability and bond length for a set of 5 different compounds, which are, well, different variants of oxygen in itself at different charges. The reason why this is very important is because these are the 4 parameters which you're used to measure in all types of question, and this question itself has come up in IIT JEE over the last 10 years in different forms. So watch very carefully as to how Devansh goes about solving these questions. So Devansh, how do we start with the bond order for O2?
This is the basic question of molecular orbital theory, and as we know the basic formula for oxygen and above oxygen systems.
So what is an above oxygen system?
Above oxygen systems are the systems which have more number of electrons than oxygen.
Okay, alright. So more than 16 electrons basically.
Yeah. Now, the formula for it is sigma 1s, sigma 1s star,
Sigma 2s, Sigma 2s star, Sigma 2px, pi 2py equal to pi 2pz. This equal to is very important and we'll come back to it soon. Pi 2py star equal to pi 2pz star, and then eventually sigma 2px star,
and so on.
Okay, so now that we have it, how about we start allocating the 16 electrons that oxygen has in it?
As we know, oxygen has 16 electrons, therefore, and we know that all the orbitals like 1s will occupy 2 electrons at a time.
Okay.
Therefore, as oxygen has 16 electrons, let us see how to fill it.
Alright.
2 over here.
Okay.
Then
Two
once the one orbital has got 2 electrons, then it move in next one.
Okay, so once we filled it up, only then do we move on to the next orbital as such. So we filled up 4 now, then we fill up another 2 in sigma 2s, another 2
और
in...
ऐसे ही 10, 12, अब पाई टू पी वाई एंड पाई टू पी जेड में सबसे पहले हम एक इलेक्ट्रॉन भरेंगे. अब जो नेक्स्ट इलेक्ट्रॉन है वो पाई टू पी जेड में आएगा, क्योंकि वाई और जेड की जो एनर्जी है वो सेम है. और अब जो सेकेंड इलेक्ट्रॉन आएगा, थर्ड इलेक्ट्रॉन, it will come over here and the fourth one will come over here.
Okay, so 15th and 16th will come one by one as opposed to coming in together.
हाँ, इसका बेसिक रीजन ये है कि एज पाई टू पी वाई एंड पाई टू पी जेड की एनर्जी सेम है, तो इसलिए उन दोनों में पहले इलेक्ट्रॉन चले जाता है और दूसरे इलेक्ट्रॉन को थोड़ी सी पेयरिंग एनर्जी चाहिए रहती है, इसलिए वो बाद में डबल होते हैं. अच्छा,
so it's pairing energy, that's the reason. All right. So now that we've allocated
14 electrons right now and we know that there are total 16 electrons. तो जैसे हमने आपको बताया इधर, अब फिर इधर एक इलेक्ट्रॉन आएगा और उसके बाद इधर एक इलेक्ट्रॉन आएगा.
Yes, students, you should be very careful and ensure that you don't put in 2 electrons into pi 2py star, because that would make the question wrong, because pi 2py star and pi 2pz star are equal energy orbitals and one electron will enter them at each point of time as opposed to both of them entering together, because the second one will have a higher energy. So now we've allocated 16 electrons in the molecular orbitals.
और ये सिस्टम गलत है. This is wrong.
Okay, so no 2 and 0. All right.
So अभी यहाँ पर जो सिग्मा स्टार वाले हैं वो एंटी बॉन्डिंग मॉलिक्यूलर ऑर्बिटल है, और जो नॉन स्टार है वो बॉन्डिंग मॉलिक्यूलर ऑर्बिटल्स है.
Okay, so how will we calculate the bond order now?
हमें बॉन्ड ऑर्डर का फॉर्मूला पता है. It's bonding molecular orbital minus anti-bonding molecular orbital by 2.
So you mean number of electrons in bonding molecular orbitals minus number of electrons in anti-bonding molecules,
Yes.
molecular orbitals divided by 2. Okay, so
Yes.
let's calculate the number.
As we know that in bonding molecular 2, 4, 6,
6.
here 4, it makes 10. So
Okay.
it's 10
And
minus
anti-bonding will be 6.
6 by 2.
So we
which
get
is
2.
2.
Alright, very easy now
Huh.
that we look at it.
So the bond order of O2 is 2. And for checking whether a molecule is paramagnetic or not, we know the condition that there should be no unpaired electron.
So if there are no unpaired electrons, is it paramagnetic or is it not paramagnetic?
It is non-paramagnetic.
Okay, so if you have unpaired electrons, it will be paramagnetic. Fairly simple.
Which is also diamagnetic.
Okay.
क्यों काट रहे हो? Diamagnet. But
Okay.
as we can see over here, we have 2 unpaired electron. Therefore, O2 is paramagnetic.
Okay, and what about the other two things, which is bond length and stability? How do we measure the two of them?
Bond length is inversely proportional to bond order,
Okay, and stability?
stability is directly proportional to bond order.
And what about bond strength? What is the relation between bond strength and bond length and bond order?
Even bond strength is directly proportional to bond order.
Okay, so it means it's inversely proportional to bond length.
Yeah.
Okay. So I
So
think we have
we
it
can
sorted.
say
Once we can calculate the
bond
bond
order.
order for each and every molecule that we have, we'll be very easily able to identify their stability as well as their bond strength as well as their relative bond length vis-a-vis the other substances present with it, right?
Yes.
So why don't we now try and find out the same things and figure out a trend between the 5 things that we had, which is O2, O2 minus, O2 minus, O2 plus and O2 plus.
Yeah.
So now that we're done resolving this for O2, let's try and solve it for O2 minus and see what happens.
O2 minus. O2 minus is basically O2 plus electron.
Which means we have 17 electrons.
Yeah. Now there are total 17 electrons and we need to arrange them. So basically it's nothing like here is the O2 one which we have already solved, and now just only one electron is added to this system. तो वो electron P2Y में जाएगा.
Okay. So consequently our bond order will now change because there is another electron in the anti-bonding molecular orbital. So it would mean our bond order coefficient would now become 10 minus.
Yeah. Now our bond order will become 10 minus 7 by 2, 1.5.
Okay, so as you can see, it's lesser bond order than O2, which tells us that O2 minus is also less stable than O2 and also consequently has a greater bond length. Let us try and see if O2 minus will also be paramagnetic.
Yeah, O2 minus will be paramagnetic because it is having one unpaired electron.
Okay, so because we have one unpaired electron as such, we also know that O2 minus is paramagnetic as well. So here we have it. We figured out the same values for bond order, paramagnetism, stability and bond length for O2 minus as well. Now let us try and move on to O2 minus. Oh, before that, tell me.
Yeah, before that, the main principle that we have put the electron in P2 Py is that जब भी कोई नया इलेक्ट्रॉन आएगा तो वो सबसे लोएस्ट एनर्जी अनऑक्यूपाइड मॉलिक्यूलर ऑर्बिटल में जाएगा जिसमें इलेक्ट्रॉन की वैकेंसी हो. दैट्स वाई वो P2 एंटी बॉन्डिंग सिग्मा 2 Px में नहीं गया और वो P2 Py Pi2 Py में गया क्योंकि Pi2 Py खाली था.
अच्छा ठीक है. तो अब यही सेम चीज हम O2 2 माइनस के लिए भी ट्राई करते हैं. O2 2 माइनस में बेसिकली हमारे पास हो जाएंगे 18 इलेक्ट्रॉन. और तो अगर 18 इलेक्ट्रॉन हो गए हमारे पास तो हम बॉन्ड ऑर्डर हमारा कैसे चेंज हो जाएगा?
बॉन्ड ऑर्डर में बस कुछ नहीं हो जाएगा. इट विल बी जस्ट 10 minus 8 by 2 which is going to be 1.
सो बेसिकली जो पाई 2p2 स्टार है उसमें हमने अब एक इलेक्ट्रॉन और ऐड कर दिया है. सो as you can see very clearly that there is no unpaired electron that's available, which would mean that this O2 2 minus is not paramagnetic. That is, it is diamagnetic, right?
Yeah. O2 2 minus is diamagnetic.
Alright, so it is diamagnetic, has lesser bond order than O2 minus and O2, which consequently means that it is less stable and has a longer bond length than the two preceding molecules as such. So now if we have to try and solve it for O2 plus, can we just remove one electron from pi to pz, or how do you think we should go about it?
Yeah, for O2 plus, it's basically O2 minus electron.
Okay.
Therefore, an electron should leave.
Okay.
So the electron will go away from pi to pz.
Okay. But Devansh, I have a question for you. So we do know that we follow one methodology for oxygen and above oxygen, which means more than 16 electrons or equal to 16 electrons. But now that it has become equal to 15 electrons, right? Will we follow the same order, or is there a new order that we will have to look at?
We will follow the same order for this because it's basically an oxygen derivative. For the compounds that are below oxygen like nitrogen and its other derivatives, the formula changes a little bit.
Okay, so even though it's becoming lesser than 16 electrons, just because it is an oxygen derivative, we will not use the other formula, right? So similarly, if it is a nitrogen derivative with more than 14 electrons,
so the formula for that nitrogen and lighter system is,
but we will not be using this formula, right?
Yeah, we will not be using this formula. The formula for that is sigma 1s star, sigma 2s
star,
2s star,
sigma 2py.
No, pi.
Oh, pi 2py. I'm sorry.
Here the changes.
Alright, so sigma 2px is not going to come here. Sigma 2px will come after.
Now sigma 2px will come.
Oh, alright. Followed by
sigma 2px star.
Alright. This is slightly confusing, students. Remember to keep the order in mind very, very carefully and not to mess up the order. Also remember where you're supposed to be using the order, as Devansh clarified. Even though the number of electrons have now become lesser than 16 as such, we still cannot apply the equation that's used for N2 and the lighter system consequently. We still have to use the same equation that we were using earlier.
The O2 plus system, the electrons has become 15 electron, and now the bond order is 10 minus 5 by 2, which is 2.5.
So this tells us that an O2 plus is actually more stable than an O2, or even more than an O2 minus, and obviously more than an O2 2 minus as well.
Yeah, this is what molecular orbital theory suggests, that O2 plus is more stable than O2.
And what about its paramagnetic nature?
As you can see in this we are removing one electron from pi to pz
Okay.
for O2 plus.
Okay, so it
And
means we still have
one electron is left.
Okay.
So still O2 plus is paramagnetic.
Okay, so O2 plus is paramagnetic, as we see. Okay, so now that we know O2 plus is paramagnetic, we also know that in terms of bond order, it has a higher bond order than O2, O2 minus, O2 2 minus, which means it's more stable than all of them as well. And consequently, its bond length is also shorter or longer?
Its bond length is shorter, as it is in bond length is inversely
proportional. All right, we should always remember that. So let's quickly try and solve it to O2 2 plus.
And for O2 2 plus, it's now become the bond order is 10 minus 4 by 2, which is 3. And as we know, we have removed the last electron from pi star 2py. Therefore, it has become diamagnetic.
Yeah, because we don't have any unpaired electrons left, right?
Yeah.
So we know that O2 2 plus is diamagnetic in nature, has a stronger bond and has a higher bond order than O2 2 plus, O2 plus, O2, O2 2 minus and O2
so
2.
Just for the reference, I am writing the bond order of all. Bond order O2 2 plus, then O2 plus, then O2, then O2 minus, then O2 2 minus, and this is 2, 2.5, 3, here basically it's 1.5, and here it's 1.
So basically, as you would have seen in this question, we figured out how to be able to calculate the bond order, the correlation of the bond order with the stability and the bond length, and how we need to be able to arrange the electrons in their particular molecular orbitals before we can calculate paramagnetism or bond order for either of these compounds. Now that this concept is clear, we should also remember and keep in mind the other methodology which is used for N2 and lighter systems, and remember the difference between the two, and very, very carefully remember that even if it is less than 16 electrons, if it is still an oxygen derivative, you have to continue to use the formula that was mentioned. So now that we know this, let's move on to the next question. We should also, and as a very, very small note, I think Devansh also wants to tell us as to what happens when the bond order becomes equal to 0, because that's a possibility, right?
Yeah.
That
when the bond order becomes 0, like in the case of He2, which is sigma 1s, sigma 1 star, as He2 contains 4 electrons, so 2, 2, so bond order is 0, the molecule doesn't exist.
Exactly, and we know this from our observation, right? We know that there is no such thing as He2. We know that helium exists on its own, and as you will see, this molecular orbital theory also perfectly complements the theory of noble gases, because if you try and arrange all of them in the molecular orbital system, you will all realize that the bond order for all noble gases ends up being 0, as a consequence of which we see that a molecule doesn't exist, that they all exist as individual atoms.
And moreover, you have also seen that the bond order can't be negative, because there will be always a bonding molecular orbital with a lower energy before an anti-bonding molecular orbital.
Oh yeah, you can never have it as being negative, because we will fill up this one first. So the lowest it can go is 0, or yeah, that's about it.
That's it.
So with this, let's move on to the next question. I hope we've all been made very clear on paramagnetism, bond order, stability and bond length, and how to calculate them for each and every compound.